All right. Welcome back to another episode of Bourbon Bytes. I'm Terry McGraw from Cape Endeavors Incorporated. I am very blessed to have the great Christopher Perry here today. Christopher is the head of Cybersecurity Product Management for Google Cloud Compute. Also a former soldier, West Point graduate. You have a master's degree from Georgia Tech, both in cybersecurity. Neither one are slouch engineering schools. I know they're really low down on the tier, but no, just kidding. You're kind of a man of many talents, not only an exceptional academic and very brilliant in cybersecurity, but you're also a Ranger, former combat veteran as myself. In fact, you and I served together downrange, well, at least tangentially anyway. And so I'm very, very blessed to have you on. So Chris, thank you for joining us this morning.
Absolutely. No, my pleasure to be here.
So, just real quick for a level set, as we said, your title's a mouthful. And so, what exactly does your duties entail over there at Google? You've been there about 3 years, I understand.
Yeah.
So how does that construct work from the cybersecurity perspective?
Yeah, no, so it sounds good. Yeah, mouthful is probably a polite way of phrasing it. So, Google's a big company, right? 180,000 or so people. And Google Cloud Compute is the infrastructure layer that allows us to serve our workloads both internally and externally. So I focus on solving the cybersecurity product strategy for things like Google Compute Engine and persistent disk. So if you hear about all the CPUs, the GPUs, the TPUs that are used to run workloads with a major focus on AI workloads, I'm the one that's allowing us to make sure that we can serve the needs of our heavily regulated and sovereign customers, as well as our own internal security needs. So that's how I spend my time.
So that raised a good question. I wasn't actually planning on going this way, but it is rather interesting. In the sphere of cybersecurity, given that is your sphere of responsibility, how do you handle supply chain management? I mean, I assume that you're worried about the security of your procurement of chipsets and hardware, et cetera. Does that fall under your purview? And does it?
So the actual procurement of the hardware is outside my purview. So I'm more focused on the control plane layer. So there's a whole data center operations team that's responsible for installing, securing, procuring, and getting those components set up. My focus is more on the logical layer, where how do we make sure that we have the data residency, the access transparency, the customer encryption key, all those types of capabilities. How do we make sure that those are in place such that the GPUs and hardware are available to those customers? So I touch it tangentially, but that's not a core focus.
Is that a global responsibility, or are you you guys do this regionally, or how do you break up the responsibility there?
That's absolutely global. So Google, as a major cloud, we're third place compared to Azure and AWS in total size, right? So we came to the market a little bit late. What AWS and what Azure have done is they set up a gov cloud, right? So when they wanted to serve sovereign workloads in the United States or externally, right? And they wanted to make sure that those customers were comfortable purchasing those cloud workloads. They would create a separate data center saying specifically hey, you guys will have this specific data center. It's just for you. So you can have this faith and confidence that it's only your passport citizens that are touching it and entering it. Your data is not going anywhere and being mingled with other types of workloads. And this was really successful. You got to give credit to those organizations for being successful in making cloud something that these governments and organizations were comfortable to purchase. Mm-hmm. Because Google came a little bit later, we came up with a different style approach where we're using software-defined controls to try and create the same security guarantees. So instead of having to create a separate data center for these organizations, we're saying that we can give you the software-defined controls that allow you to still have the type of sovereignty requirements that you need in order to have the faith and confidence to purchase on top of Google. And the reason that answers your question is because it means the things that we're doing to solve it regionally here in the United States extend perfectly to all of our other data centers as well. So we can build once, deploy many, and that's what's allowing us to be able to kind of catch up in some of these areas.
So I do a lot of speaking at conferences around the current cyber threat landscape. And now I speak mostly from a corporate and to a lesser extent, sort of the nation state threat and how it plays out in the corporate environment. Cape Endeavors is clearly a commercial entity, and we support the defense industrial base. But that said, in the cloud provisioning world, it's a completely different set. Well, I would expect it would seem to me that you have the same threat landscape, but a completely different set of worries in your environment. How does cybersecurity differ from a cloud provider perspective than a consumer, if you will, of those services, or someone who might be in a hybrid kind of environment?
Yeah, so Google has what's called the shared fate model, right? So it used to be, right, that you would have like a hardware device, you would ship it to, say, the intelligence community, to the DoD, they would install it, and from day one, right, they would have to set up the operating system, they'd have to set up the software, they'd have to do patching, they have to do all of that work, right? With cloud, right now, some of that infrastructure burden comes on us. And so what we've taken a look at is how do we manage to make sure that we are able to provide you that level of infrastructure and to eliminate the need for those organizations to have to worry about that. So we're worried about the lower level of the stack. How do we make sure that no one's getting onto those servers? How do we provide things like confidential compute? Is it large growing capability where it can provide data in use guarantees? How do we make those things available to those customers so they don't need to worry about that at all? But that doesn't mean they don't have to worry about security, right? There's the share fate, their portion of that. They still need to take a look at the applications that are running on top of the cloud workloads, and they need to make sure they're securing that correctly, that they're setting up their identities correctly, that they're kind of locking the door to the infrastructure that we're securing. Because if they leave the door open, right, then someone can still just use a pilfered credential, log right in, and have access as if they'd hacked the infrastructure themselves.
I'm almost chuckling because I get this question every now and then from customers. How do I know? So, for example, when we're in the CMMC arena, and you inherit security controls from your cloud provider, there's an entire category around inherited controls, and well, I tend to get questions around that, and the reality is, it's sort of like if the third string wins the Super Bowl every year, I don't need to like bring out my first string. Like, so if I can break into your environment just by all of the holes that you have in your environment, I don't need to worry about your cloud provider. But
there's a lot of truth to that, right?
Yeah.
Like organizations are always going to be inherently lazy. Why would you go the hard route when the easy route works?
Exactly.
Right. If I could just take a credential that was leaked and log in, why am I going to try and use a 0-day exploit? That's just common sense.
It is. Well, we see a fair amount of, actually, it's funny, guys, over the years I've been given this, the three top initial access vectors have been the same three. It is stolen credentials enabled by lack of MFA, malware born through phishing, and the last one, of course, is the unpatched systems, period, right? I mean, whether it be 0-day or just legacy crap in your environment.
Those unpatched systems are very rarely 0 days. Generally, it's a exploit gets known, and then within 24 hours, it's weaponized, and teams can't patch that fast. It's just not not a reasonable expectation. And so those exploits are used to log right in.
Yeah, when an SMB v1 was like when Eternal Blue dumped, it turns out that the patch had been released 15 months prior to the Eternal Blue dump.
Yep.
And it was, to me, it was a pretty sad indictment on organizations that got popped for that, because the patch had been available for over a year, and you waited till it became headlines before you did anything. So anyway, I see
that led to multiple iterations, right? You had WannaCry, the first iteration that went out as a worm and destroyed a bunch of organizations, and then not long after, NotPetya went out, and I think that one had $10 billion worth of damage. So I mean, and we can. I don't want to victim blame, right? Obviously the patch was available, but patching is also hard. I spent a lot of time with IT teams. It's something easy to preach, sometimes hard to execute, and that's the reality that these organizations have to live in.
Well, I had a previous guest, and we talked about this. So I think you and I both worked at the org at the same time Jen Easterly did. And as CISA director, she's very big, or she was very big on trying to secure the software supply chain. Meaning, I think that the money that corporations and the government spend on commercial providers of software, we should be demanding a higher standard of security. It should not be just accepted that we have Patch Tuesday. Sorry, I mean we should not just accept the fact that there's going to be holes in my C libraries underlying my code, right? I mean, I think we should demand a much higher set of standards for those providers. Do you share that view?
I mean, absolutely, right? You take a look at like SolarWinds, right? We're very fortunate that in that endeavor that the Russians were clearly interested in doing foreign intelligence gathering, because if they had weaponized that access in the way that they weaponized NotPetya, that would have been a dramatically different end state, right? That would have been, 10 billion would have seemed quaint in the damage that could have done had they tried to weaponize that fully against all the accesses that they had through that. These watering hole attacks are quite dangerous, and so if they're able to get a good watering hole, right, it can be a massive incident for the entire nation. Right? So I agree. We got to secure the supply chain, and I think that's another area where legislation is good, because while a great organization is going to be doing these things by default, not every organization is going to be great. And that's where audits and that's where regulation can play a pretty good role of raising the bar of requirements for all.
Yeah, well, it's actually demonstrable. I'm fond of saying that compliance isn't necessarily security, but it is absolutely demonstrable that in more regulated and more compliant oriented market verticals, you see a much lower percentage of cybercrime exploiting their environments. Like the financial sector does much better than manufacturing, for example, right? I mean, so we do see that compliance does have an overall improvement in cybersecurity just based on your following a roadmap that you have to attest to, right? It's the whole beauty of the third party attestation.
Yep. And it's such an interesting double-edged sword, because you're absolutely correct, right? Compliance does raise the bar, but also we can't be stifling innovation for the smallest companies that don't have the budget or energy. And so trying to find that right balance between how much requirement do we put on these organizations to make sure they get it right, combined with how do we enable organizations to move fast and deliver value and innovate and grow, is a really challenging problem, right? That's why we hopefully elect and pay good people to try and work and find the best balance. It is a uniquely challenging problem.
It is, and it is also the balance. I mean, you avail yourselves of a lot of inherited security controls by using a cloud provider for that innovation cycle, and providing the infrastructure that you can operate on. And there's several cost models, but if you don't do it right, it can become incredibly cost prohibitive, right? So I mean, that's the other thing is just like having a complete on-premise or hybrid environment. If you don't do it right, you inherit a lot of problems.
And I think in the digital natives, right, I think we do see a relatively higher bar, at least than we did like 10 years ago. I mean, I think that's improving in a very strong direction. I think the areas that still have to play a lot of catch up is all your IoT devices, all those smart refrigerators. I mean, those are organizations that are not necessarily as naturally tech savvy, or at least IT savvy, as a digital native, and trying to add all these features, and it can lead to some pretty bad outcomes.
In the early 2000s to mid 2000s, when you and I were still in the Army, we remember when printers started to be exploited because they have RAM and they've got CPUs, and they have IP addresses. Oh crap! We may have to include those in our procedures for lockdown.
Yeah, I mean, denial-of-service attacks are not like the headlines that they maybe used to be, but there's some pretty major ones out there. And they're pretty much all IoT devices. And you think about all these like home camera systems, right? You need a lot of bandwidth in order to be streaming video. And if you take all of the home cameras in the world and point them at someone's server, even Amazon's going to struggle. Right?
Yeah, it was. It's at least the last thing I read. It was non-attributable. We don't know the threat group who did it, but the largest denial of service attack ever launched via IoT devices, and it was some ungodly amount of terabits per second that just flooded certain regions of the world. And I don't know if it's a proof of concept test or what, but I mean, we hadn't seen volumes like that in history. So the problem still persists. It's not like that threat went away. So
no, not at all. I mean, I'm pretty sure on the dark web you can still go and like rent them. It's denial of service as a service.
Oh yeah, all of them can. Actually, it's interesting. We've seen the dark market, if you will. It's created many niche sub-markets, and what we're seeing is a resilience and diversity of that marketplace that allows affiliate groups to have far more latitude and what kind of tools they use. It adds for obfuscation. It adds for lack of attribution. It also adds for a lot of resiliency when infrastructure gets taken down, et cetera. It's why we always see these resurgence after a big takedown. But
I mean, it's downright professionalized. Right. I mean, it's been a few years since I've gone on, but I remember looking at GanCrab, one of the Ransomware-as-a-Service organizations, and you had to submit a resume to join their organization. I mean, it was like a professionally run company. They had 24/7 support if you needed help using their tooling that would make most major professional companies in America cry how good it was. Right. Like they actually answered and solved your problems. The initial access brokers, I mean, you could get exact. I mean, it was amazing. Access to this company using this device with this level of privileges. You could see the list, see the prices, just price it out. I mean, you could almost, without having to write a single line of code, just procure, integrate, and launch attacks. So it really democratizes, right, and reduces the barrier to entry for an aspiring criminal. It's
interesting. It's you mentioned internet access brokers, et cetera, and the challenge if you're a defender on this regard, and this is something that I remind a lot of my customers who've suffered from cybercrime. You actually have the affiliate group that hired or that bought access from an IAB.
Mhm.
So you'll end up paying the extortion money for your data to eventually be deleted, at least the promise of deletion. But we don't know who the initial access broker is, right? I mean, or rarely. Like, there's rarely a smoking gun that says this was the IAB who did the initial access. But there is still data theft component to that, because that's the proof of life data they use to sell to the affiliates. Like, here's the access I actually have. And we never really talk about that. So I remind people in audiences, if you've been a victim of a ransomware group or a data breach compromise, you've actually been a victim more likely by two different groups. And it's not as straightforward as, dealing with just with the affiliate group. So I always say that the risk is not going to be near zero. You always have that you've lost data in both components. And this is why when I talk about CMMC compliance, it's not just nation states we're worried about, right? There is a huge problem with nation states stealing our R&D, and we're funding it. But if you lose data to a ransomware actor, the DoD data still left the back door. I mean, like, it's almost worse, because you have no ability to say that, at least, it was China that took it. We know the purpose of that. But, with ransomware actors, you have no idea where it goes. Then you get some.
I think you're spot on with that. I think 2 is probably like the minimum. It could be even quite a bit more as you start to put together the pieces that go into those attacks these days. So,
Absolutely.
I fully agree.
Hey, I want to pivot a little bit. I've been probably more down on AI than I should be, I'm not down on it because I don't see the value in it. But you cannot deny that it's changing the job landscape. And a mutual friend of ours I had on, Mike Wagon, kind of challenged me on this. He's like, yes, but if you're smart, it's like you use a computer every day. It's not like you're whipping out your IBM Selectric to go type something because this new technology is like it's endangering my job. I mean, the reality is it's here, it's capable. Are there pitfalls? Absolutely, but it's a new technology, and you'd be foolish not to embrace it for your advantage. Now, you say that, but if you're looking in Hollywood and your job just went away because an AI generated commercial can do it all in 30 seconds, it's a bit of a double-edged sword. So I wanted to get your take. You clearly, in the cloud space, you're provisioning for AI. You have a deep cybersecurity background and a deep computer science background. What is your take on the pros and cons of AI? It's not going away. It's here. What do you recommend for folks to either embrace or mitigate?
Yeah, I would recommend to anyone to start using it, to start playing with it, because it is a fairly transformational technology. But like any technology, right, there's going to be good and there's going to be bad from it. Change is change, and trying to, I think, have this like a single label for it is a bit naive, right? Alfred Nobel invented dynamite. Phenomenally useful for construction, also had some other uses, right? So like I think like anything, AI is going to have that. We use it pretty regularly at Google for all sorts of internal tasks to speed up how we do things and to reduce redundant tasks. Like an example, right? Say we need to update a little test that we want to put on each of our methods, right? Like an API call. Well, like in just my main API, I have 3,000 of those, right? So how did it used to be? Hey, junior software engineer, go do the same thing 3,000 times, right? And they're not quite copy and paste, right? So you have to kind of like look at them. That would take months of their time, just kind of repeating. That's how it used to work, right? Now with Gen AI, hey, go spin up this test, train it on a couple, boom, launch it. Then you just get a code review. I mean, now they could do it in a week, right? Like it really is super useful when applied correctly. We also just saw, right, that there was a recent model that launched to the top of a chatbot that launched to the top of the market right now because it's selling anime porn in Japan. I guess, whatever, right? But it's just, like there's all sorts of use cases for this stuff. Some incredibly useful, some not. I mean, I think they say the greatest scientific, inventions of the past, 5 years was AI derived, and that's AlphaFold, actually out of Google, right? So I have some family members who are big into the science area, and their ability to, generate things like 200 million different protein shapes, right? The painstaking labor that used to go into a human deriving those was significant, just a cost resource, the brain power of this, brilliant researcher trying to do this, and we were able to automate it. And I think that's not going to eliminate researchers. In fact, we're probably going to have so many more researchers now because we have all of this capability here that it's going to accelerate how fast we can bring drugs to market, make it cheaper, make our healthcare better, deliver better healthcare to people because of what AI can bring and make more capable. So I think trying to call it good or bad is a bit small, right? I think it's going to be change, and some of that change is going to be beneficial and some not. I think like to an individual user, right? So someone like listening to this, I absolutely would start playing around with it, right? At first, it's like neat, right? It's just a cool toy almost, like, oh, look, it can write a poem, or it answers my question in, an Eminem rhyme, like kind of thing. Yeah, I mean, that's fun, right? But like that's not necessarily going to change my life at all. But like when I'm trying to do research now, I often will start with going to Gemini, right? And then the deep research capability. And I'll be like, all right, we're looking at this new area. I'm just interested in doing an analysis of these 5 companies on this specific tool. And it's pretty profound what it returns. And it's all documented too. So if there is a fear of it not getting it right, I can then go directly to the research. It's an amazing portal to the world's information. And to be able to use that is incredible. Like, it's just so powerful and so fast. So I would recommend anyone use it. There definitely is going to be change. Not all of it will be good. I think that's how.
Yeah, it is interesting because when you look at it as a technology enabler, there's a lot of hyperbole around, the
Yes.
quote unquote the sentient AI, et cetera. But the reality is, I don't think we're anywhere close to AIs that can empathize. And like, does an AI ever appreciate a sunrise or a sunset? Right? Like there's human components that drive innovation. We develop art and science and things for the betterment of the human condition. A machine has no betterment of anything that's required. Like, so like, oh, it's going to code itself. Like, to do what? Right. I mean, so there has to be some programmed outcome that we set these things to do. And that still requires a human. And when you look at it as with the space program of the 60s, if given today's compute power, would they still insist on using slide rules? Right. I mean, it's like, would you type your college, thesis on an IBM Selectric or a WordPress? Like, the reality is these capabilities are here. They're tremendous. They're powerful, and you should be availing yourself. And in fact, I used to really encourage people who wanted to get into cybersecurity, start at sort of intrusion analysis. Mm-hmm. The reality is software does all that now. Like, you still need to understand intrusion analysis from an academic perspective, but software is achieved level 1 or level 2 intrusion analysis now. And when I ask my folks that sort of grew up with me in SOC operations, they're like, well, remember, Terry, we spent like 80% of our time just trying to gather data to make a good decision. It wasn't like we were looking at the threat and determining the threat. We were just gathering friggin' data, 80% of the triage. And all that went away with these kind of capabilities and magnified by a trillion. I mean, now you're talking about the ability to process 4 trillion events in a day, or a week. And no human would have ever been able to consider all those data points in making decisions. So we're leveraging these things to great effect. I think as you've pointed out rightfully, it's an education process. We need to continue on, and we need people to embrace it, figure out how to use it. Yeah. If you're the wagon wheel maker in the age of the automotive, that's going to be a problem. So figure out how you can use AI to build the next automotive rather than how do I improve the streamlining of my wagon wheel, right?
Yeah, so absolutely. And I think there was a book from like 2016. So this is before Gen AI, called Human and Machine. I highly recommend it because it had like a little graphic, and it's like the only part of the book I remember from reading, 8 years ago. But essentially, like, if it's gonna be like 5 to 10% of people whose jobs like really kind of will be replaced, and those are people whose jobs are very repetitive, very automatable, right? And yeah, they might need to figure out what their next move is going to be. There's people whose jobs are not going to be, dramatically like impacted, right? Maybe a CEO, or maybe someone whose job is entirely just working with humans directly, or maybe a carpenter that has to swing a hammer, right? Like they'll be minimally impacted. And then for everyone in the middle, right? Like, it's going to be a tool that you do your job with, right? Like, my wife is an accountant. She uses Excel religiously. Excel didn't replace her, right? It's a tool that she uses to now do accounting. And I think AI is going to be like that for most people. Right? Like, lawyers aren't going to go away. Will lawyers use AI? Most definitely. Right? Like, I think that's going to be what we see.
Well, I just recently had, a bunch of medical tests, using nuclear radiological testing, et cetera. And I was just chatting with my oncologist, and the reality is AI has completely transformed the medical industry when it comes to imagery reading as well. And we are so much better at detecting disease earlier because things that would have been missed to a human eye, the aggregate data that can be processed by AI engines looking at radiology sources is so much better. And as you mentioned, drug innovations and the ability to do 3D printing and new mapping of replacement organs, et cetera. I mean, these are capabilities that we can now accelerate. I mean, we literally, the things that have been plaguing humankind forever, like, kidney failure and liver damage and, heart replacement, valve replacement, et cetera. The ability to start looking at truly innovative medical appliances that can replace, human tissue effectively.
No, it's very true. I think we live in a world that's gotten very used to focusing on like the negatives, and this isn't to downplay all the challenges that society has globally and nationally, and all the issues that we have from divergence of opinions. Those are all very real. I'm not trying to diminish those, but there's also some really beautiful things that are happening, and really amazing things that are going to be capable for our species over the next 50 years. And I think some of that excitement is also warranted.
I want to be respectful of your time, but I would like to talk about another hot topic that is I don't think it's actually talked about enough, except in smaller circles, which is quantum compute, and what it means for traditional encryption. And I have a friend who's at IBM, and he said, "Hey, we've been working on." And I'll be honest, this is something that you are able to speak about more than I can because your mathematic abilities always stomps mine left and right. But looking at quantum resilient algorithms for encryption using today's compute, not necessarily a quantum compute, but using fractal mathematics, et cetera. Can you speak to any of that from your academic or cybersecurity background?
Well, I appreciate the compliment. I'm by no means a quantum expert. As a slight caveat, right? As quantum computers grow, I think it's Shor's algorithm, I believe is the name, that is going to be able to crack RSA encryption, kind of the default encryption that we use today. And that's a pretty, well solidified future that most people think we're going to get to. They do have quantum proof encryption, right? These algorithms that they believe the quantum computers will not be able to break. And for the most part, I think it's really just about modifying where our encryption points are and making them available and capable with this new encryption mechanism. So far, it has seemed less like a strategic challenge and more just an execution challenge because encryption is used everywhere. So you have to go to all of those points to make sure they all accept it. It's just like a large kind of like rollout kind of challenge more than some type of like, how do we do it conceptually? And more like, how do we do it practically? Like, how do we get all these places to actually support this newer encryption?
Well, so I guess if I'm a CFO, the question I have is, do I need to go out and buy all new hardware to run this stuff? Like, I mean, what does it mean? Because if this comes in 18 months and you've evaporated, RSA and AES encryption capabilities, like literally now I can just obviate it. That can I create quantum resilient encryption on the current hardware? Or am I going to need to rip and replace hardware stacks or avail myself to some level of resiliency in a Google product? Like, how do you recommend we handle that?
Yeah, so I think if you're like the CFO of a normal company, I would recommend a traditional enterprise, I should say, right? I would start to demand of your providers, right, your supply chain that we mentioned earlier, that they have a specific capability added in to the new items that you are procuring. Would I go out and replace everything that I have right now? I don't know that I would necessarily jump on that immediately. That maybe depends on the organization. If I was in defense, if I was in, some parts of government, I think that would maybe make a little bit more sense if they haven't done that already. If I was, say, the CEO of a hospital, I don't know that I would as urgently be going down that road. So I think you have to take a look at your risk. And then I would push on your vendors. Make sure this is something that's built into your future strategy. So as this capability in quantum comes out, you're going to be able to meet that more elegantly. But I wouldn't necessarily be jumping for. I would wave the red flag and jump.
Yeah. So if you were, well, I guess I'll re-ask the question in this. So and that's, by the way, sage advice as always. If quantum, I'm looking at the sphere. Like the president or the former president of Google said, in 18 to 36 months, we're going to have, AI reach a singularity, etc. I mean, like, he's making some dire predictions. We have folks that on the quantum side, said in 3 to 5 years, we're going to have, quantum capabilities that absolutely obviates our encryption capabilities. So let's assume that we're at the 5-year mark, somewhere between 3 and 5 years. That's about a normal depreciation schedule for a corporate entity anyway. So given that though, but would you say that when that switch is flipped, and this capability now rolls out, quantum capability to break algorithms comes out, whether in nation state capability comes first, then I would imagine we'll have high-end academic and, or I should say research and development, capabilities that large cloud providers will all have capability. Google has capability now. Let's assume that trickles down and we have that switch is now flipped for wide acceptable use. Do you think that 3 to 5 years, A, is accurate, and B, is there a legacy? I guess what I'm trying to say is that if I'm a CFO and I know this is coming, and I know I'm going to have to start asking my supply chain, and I've got 100,000 people across the world, in different areas, and I've got a lot of hardware that's left out there as legacy. I wouldn't worry about it, but when would you worry about it? Like, do I start calculating this on my next depreciation schedule, or do I think that it's still? Do you think it's still practically 10 years away, and this is probably not something I need to put on my roadmap?
Yeah. So if you're asking me to give a prediction for when Shor's algorithm will be functional, I think I would struggle to give that. In fact, I've spoken with enough true quantum experts and have had such diverging answers to that same question that I think even the people working at the cutting edge are not necessarily aligned on how long that will be. I've heard some lower than 3. I've heard some 10 would be gracious. So it really is. That's the beauty of research. People think research is like this nice line. It's not. It's like step ladder, right? Yeah. And so like when's the next step can be 18 months. It can be 18 years. It's sometimes hard to make those guarantees. So I think 3 to 5 years is certainly a reasonable thing to plan for, especially if you don't want to be caught unaware, right? So let's I think that's a reasonable metric for a leader to have into their risk profile and codified in their risk metrics. So I think that's a fair one. And then how do they start managing it? I think, again, I don't know that I would necessarily start to deliberately depreciate hardware specifically to address this. I would make sure new hardware I'm procuring does support this. And then if and when, right, say 3 to 5 years, right, this does come out, right, your hardware that's running your most, business important applications, your most critical applications, your most sensitive data, your customers' PII, those things, right, you can prioritize and focus to make sure that those are most secured, which should be kind of a prioritized tiering already. And then you can, work to close your gaps as necessary. I would say what we've been seeing in the market from most companies worldwide, everyone is looking at it. Everyone is starting to do, I'd say, like early preparations. But again, no one outside of maybe some like intelligence community and some of the most sensitive areas is like ripping and replacing stuff yet that I've seen, at least. And again, this is not a quantum expert, but I've not run into any urgency around rip and replace.
No, but aside the self-deprecation, you are one of the most intelligent people I've ever worked with, and you may not be a quantum expert. You have certainly the ability to understand it to a degree that most folks can. You have a command of very esoteric topics, so I think our audience can trust your assessments.
Nicest way of calling someone a nerd I've ever heard, but thank you.
But gee, now I just lost my final point. Oh, I know what it was. So. There's some in that step function is the unintended consequences of new capabilities. They're better, but it also requires sort of lagging industry to adjust. And I'll give you an example. So remember when our networks moved into, from the old X25 and switch networks, and we came up with full, TCP IP, and then we added encryption. Our WAN pipes and our ability to actually do transmission was hampered because that encryption added like overhead bandwidth that the systems at the time couldn't handle. Will we see a similar need from cloud provisioning, for example? Like already, like I have customers that complain tremendously when trying to migrate big amounts of data using cloud providers because they get throttled, right? I mean, those resources are expensive, and what they would think would take 3 hours takes 3 days because they get throttled, and it's just a matter of allocation of bandwidth. Do we feel with quantum resilient capability, like the Shor's algorithm or whatever the other fractal math patterns that we're using, is it going to add that extra layer on top of our communication paths? So now we're even looking at bigger pipes that I have to procure or account for if I'm a network engineer for a big corporation.
Yeah, I don't think so. So what I've seen on the Google side, at least, is the specialized hardware components that actually have the new quantum proof encryption on them. Because it's hardware based, they seem to operate with the same level of efficiency that the prior ones did as well. If you were to try to replicate it without hardware, as in you're now applying an extra encryption layer on top of your device, you can probably expect some performance degradation. I think you're going to find it probably like the 3 to 5% is usually what we've seen when we've had to apply a software encryption layer on top. Which, if that is, if you're, say, a bank that's doing credit card processing, that would be really, really important. If you're, a tier one, like a Target.com, Amazon.com, I think that'd be really important. I think for most organizations, that's probably not as critical of a loss. So I think it depends on one, how you're implementing it, and two, like what your SLOs are, and what type of performance hit you can take acceptably if you're doing it with a logical layer. And again, I think the hardware layer is probably going to be no major change.
Right. That's fair. So last two questions I have for you. You are a cybersecurity product manager for cloud compute. That's a pretty impressive position to be in if you're a cybersecurity person, right? It assumes a lot. That you're well versed in not only computer science, telecommunications engineering, cybersecurity, but also the pragmatic application. Where does Chris Perry go for cybersecurity, threat intel, threat read? Where do you go to stay sharp on the landscape? Like if you were going to make a recommendation for a reading list, what does Chris Perry wake up and read every morning?
Yeah, so I think I would recommend two things, and one is maybe self-serving to my job, but it's actually quite good. But Google acquired Mandiant and now has Google Threat Intelligence, which was all the threat intelligence that Google has, as the backbone of the internet, as well as Mandiant specific research from doing all incident response. They produce really good literature. I also really like a podcast called Risky Business. It's a special podcast that's specifically just on your security news once weekly. I think it's a really high quality one. So if you're not familiar with that, I recommend checking them out. But they do a really good job. There's some good banter on it as well, weekly from the host. So I think that's a good one. And then third, I think like if you like LinkedIn has actually become a really, really useful tool, because I just started following people I found interesting. I think it's how a lot of people use Twitter. Previously, I was never a big Twitter person, but with LinkedIn, people just share a lot of really interesting research and ideas nowadays. Again, it's a social media platform, so you are starting to get some of the noise that social media has. But I'd say the signal to noise ratio on LinkedIn has actually been really high for me. And I think that's, if you go and just follow interesting people, you're going to get some interesting stuff.
That's excellent advice. I appreciate that. So my last and final question to you, Chris, before I sort of open up to you for closing remarks, it is Bourbon and Bytes. A, do you still imbibe? And B, if you do you have a favorite flavor of bourbon, or what's your other preferred cocktail?
Yeah. So bourbon's still probably one of my top favorite drinks for sure. I've definitely gotten hooked on Blanton's, which is
Really?
a really, really annoying thing to get hooked on because it's not like cheap or easy to find. But when a friend brought it over, it was kind of just like one sip, and I was like, oh, this is exactly how I like my bourbon. So I'm apparently very bougie on my bourbon. It's not something I intended to be. I'm not bougie in most of the other parts of my life, but in that specific case, absolutely. I've also been really getting into mezcal. So a good buddy from West Point actually started mezcal company. Actually,
All right.
here, yeah. So I support his company a lot. I also find it to be very interesting. I've actually gone down to Oaxaca and seen it distilled. It's a really, really amazing beverage, both straight and in cocktails. So it's probably my two of choice.
That's awesome. Well, I appreciate you sharing, as always. Final thoughts for the audience before we wrap it up, Chris?
No, I appreciate you doing this. It's amazing to see what Cape Endeavors is doing. I just think back to those early days at Army Cyber Command when I was, young 22-year-old running around, and you were this, lieutenant colonel, just knew everything in the ways of the world, and just amazing to get to chat with you still.
I will tell a quick Chris Perry story. I've always strived to learn way more from the people that I surround myself with than I offer, and I've always been flattered by you and Mike and others saying that, hey, I learned a lot from you, because honestly, I remember when you two nerds showed up into the we're deep underground in an operations center, and where people never get to be able to see or go, and you guys whipped out. What you guys were doing for fun. I think it was one-time padding, encryption capabilities. That's some nonsense that you were working on, and you tried to explain it to me on a whiteboard, and I immediately just felt like I literally felt like Fred Flintstone at that point. I was like, wow, okay, I'm glad these young men are here serving their country, because they clearly operate on a level I cannot. And so again, I think it's amazing. You're not only a brilliant academic, a brilliant practitioner, but you're a Ranger, a combat veteran. You truly are a gift to the American citizen, and I appreciate everything you do for us.
Well, I thank you for the kind words, Terry. I still look up to you to this day, and thank you for everything that you've done as well.
I appreciate it, Chris. Thanks for joining. We'll have you back. And if you got a hot topic you want to talk about, please come on back and we'll have it. And
about hacking AI next time, do some fun stuff there.
Hey, we can do that. We can do a practical application of that. That'd be fun. That might actually really be something to dig into. So if you have one of those interesting exercises you want to demo for us, we'll be happy to give you a forum. So,
all right, sounds good.
Thanks again, Chris. I appreciate it, brother.
Bye, Terry.
Take care.